In part two of the videos on the CT-1024 video terminal from Southwest Technical Products Corporation, we're going to go ahead and power the unit I have up, do some checks and make sure it works, and if it does, we'll actually take a play with it. So in this video, we're going to take a look at the Southwest Technical Products CT-1024 video terminal. This was sold as a kit in the mid-70s. There was a series of articles in Popular Electronics that described the build, etc., and we'll take a look at some of those pages later on. I acquired this unit a decade plus ago. It was an eBay find. It was completely miscategorized, and I ended up getting it really cheap. And I'm not sure if I feel guilty about it or not. Don't actually know what it's worth. Anyhow, there's a main logic board back here where you can kind of see it beyond the connector here to the keyboard. It's just TTL logic, a little bit of analog. There's a power supply there on the back. That metal bracket provides the heat sink. I think it's a 2N3055 pass transistor producing the +5. This is a parallel ASCII keyboard. I don't really know who manufactured it. I don't think it was a kit. Anyhow, a decade or so ago, I powered this guy up and it worked. I haven't really touched it since then. Right now I have the cards removed. You can see the rows of pin headers there. We have several cards here. This is the memory card. They're 2102 SRAMs. There's 6 of them. So that provides the system memory. Down here, these are all kind of on a wiring harness. They're hard to get at. I don't want to bust a wire. We have the computer cursor. This is a cursor control board that you can send characters or open and close switches over here to control cursor positioning. So I managed to drop the camera, so we'll come back in and reshoot a bit of this. This is the computer cursor board. It allows the computer to send certain control characters that'll move the cursor up, down, right, left, home, etc. You could also hook up switches out here and manually flip switches to move the cursor around if you wanted to. The terminal will, as you type characters, advance the cursor automatically, but it gave you some control of positioning. The longer card here is the serial card. It's got a General Instruments, I think it's an AY5 1013. I know it's a 1013 General Instruments UART, pretty common from back in the era. I believe this card has the optional components on it, the crystal and some other parts to allow the baud rate to be changed. By default it was 110 baud, and by adding the crystal I think you get up to 1200 baud on it. There's one more card I have here. This was another eBay find quite some time after I bought this, and again I recognized the card when I saw it on eBay, and it's this card right here. And this is the original cursor control, so you hook switches up over here and you could flip switches to move the cursor up, down, right, left, etc. And I got this card, I think it was $5 including shipping, on eBay. I recognized it. If you didn't know what it was, you'd have no idea what it was or what it was for. The original configuration, of course, used the computer cursor card here. So anyhow, I'm going to get the camera back in the camera mount, and we'll power this thing up and do a couple of quick checks and then see if it'll still produce video. So here in the back of the shot, I've got my voltmeter plugged into ground, which should be +5. You can see the voltmeter display down here. I'm going to just apply power quickly and remove it just to see if we get a rail. Okay, we saw it swing up to 3-point-something volts and then drop off. So I've applied power and nothing. There's no power switch on this. It's just plug the line cord directly in. What's the scale on the meter? Oh, we may have overranged. Click the meter up and see if we get a 5-volt rail. We do. Okay, so we've got 5.17 volts, 16 volts on the 5-volt rail, and that's a tad high, but it's fine for now. The keyboard will add a bit of additional loading, I believe. There is a separate power supply up underneath the keyboard here. I'm not exactly sure what it was for, but because I haven't seen smoke and fire, here I'm going to leave the power plugged in. I'm sorry, I bumped the camera. And we'll look at a couple other voltages here. So let's see. On pin 5, so pin 6 is ground, -5 on pin 4. So this blue lead back here should get me -5, and it does. There should be +12 on the yellow wire, and there is. These are good signs. And let me switch over to AC. And apparently there's a 6.3 volt AC reference on pin 5. It should be this lead right here. And there's a wire in there. And it's labeled up here as well. -12, -5, +5. Those are the pass transistor. I'm not sure what the AC reference would be for, but for now I'm going to assume it's either working and I should get a good connection, or there's a problem. So I've reattached the connector here to the keyboard, and I'm just going to walk through the power supply rails one more time. So -12, -5, +5. So those all look good. So that's a good sign. So the next thing it said in the manual to do was to insert the memory card only. Get it shut off here. Insert the memory card only, and then bring it up, and there should be random garbage on the screen. So we have the memory card here. It's 62102s. There are two connectors. They're somewhat in frame back here, I guess. You really can't see them. There's two connectors back here that the card drops down onto. Now the key plug hasn't been put into this, it looks like. But the cards go in with the chips facing off to the right. So that puts in the memory card. Let me power up the terminal here. And we'll shift around. The camera here and get a view of the terminal, or the monitor. We got a raster. We do have a raster. So let's see if this thing outputs anything. And nothing. Let me recheck the video connections. So J10 is the output. Pin 5 is ground. And pin 3 is video out. I've just kind of kludged this in. These are connected here and look like they're connected fine. Check obvious things. The connections are here. I'm going to get back down to +5 just so I know I have power supply active on the meter. And I'll apply power again. And the next step of this might become... Oh! So I must have had a loose connection someplace. So we have some garbage on the screen. Let me adjust this back down. Get it centered a bit better here if I can get the camera mount to hold the camera. Hopefully that's not overwashing too much. Oops. So it's 32 characters by 16 lines. I don't know if you noticed on the keyboard, there's no return key on the keyboard. I need to hit Control M. Oh, I don't have the serial card in. So right now, there's really nothing for it to do. So let me remove the power. And this is a good indicator that it's going to wake back up. And we will install these other two cards. As you can see, this is a rather interesting jumble. So the cursor control card goes in here. Make sure I get it on the right pins. And the RS-232 card goes on here. And that's all cabled up. We have our loopback connector still set up. Let's see if we get any further. Well, it's doing something. Control M brought the cursor back to the beginning of the line. Is it Control J for line feed? Yeah, Control J for line feed. We just swap pages, so there's 2 pages of memory. But what we're not getting are characters displayed. It was a caps lock issue. So I should be able to do Control J, which is a line feed, and that will move the cursor down a line at a time. And of course Control M is a carriage return. As you saw there, the cursor jumped back to the beginning of the screen. Oops. Keyboard is really and I should be able now to scroll those off the top. It swapped over to the other page. I keep forgetting there's 2 pages of video RAM, and it alternates back and forth between the 2 by default, and that's what we're seeing happening here. I don't have any way to backspace. And I need to do a Control M, Control J, Southwest Technical Products Corporation, CT-1024 Terminal. And I'm afraid demonstration will wrap around, so I'm going to Control M to get to the beginning of the line and Control J to get down to the next line. Beginning of line, down a line, down a line. And this is 32. got a little bit of key bounce, so we'll Control M back to the beginning of the line. 32 times 16. So 32 character by 16 display. Rotate that so it's a little more aligned. Apologies for that to the camera. I think that's a little better. We'll do a Control M, Control J. It displays. Okay, Control J, or Control M, get back to the beginning of the line. It displays. Well, I can't spell uppercase. Control M, Control M, back to the beginning of the line. Upper case only. It's actually got a nice sharp display there. The articles in Read Electronics were 1975, 1976 on this. I would say the build of this is, I mean, it's obviously from that era, the PC board design. Things haven't really become super standardized yet. You know, the oddball Molex connectors for things, as they were coming out of the era of 20 milliamp kind of current loop stuff to RS-232. It's an interesting little build. And you know, it powered right up. You know, I'm not seeing the video dancing, which makes me think the power supplies are probably fairly clean. Yeah, that pass transistor is getting warm, but it's certainly not hot, which is a good sign. Well, shoot, I'd hoped there'd be a whole lot more here to talk to on this. And there's really not. Of course, I'm looking at this going, wow, I could use this as a display on my Nixie tube clock project. Boy, that would be a huge hardware hack to give it video, old school video. Now let's keep typing. Control M, Control J. It uses parallel, para-L-L-E-L. That doesn't look right. Para. Maybe that's spelled wrong. If it is, you can laugh at me. Uses a parallel ASCII keyboard. So we'll talk a bit to this. Modern computers, you've got your USB keyboard, and USB is a serial bus. So the data from the keyboard is being sent in a serial, fashion, a bit at a time through the USB bus. This happens to be a parallel ASCII keyboard, and what parallel means is all 8 of the data bits for the ASCII character are put out on 8 of the pins, and then a strobe pin is taken low, I believe, on this keyboard to say there's a valid ASCII character. So it's parallel, 8-bit, and it's outputting standard ASCII. This really is how keyboards were up to, well, the transition to serial keyboards, I think, happened kind of in the early 80s maybe, where keyboards were outputting 5-volt RS-232 serial data. But I say this is early. It's parallel ASCII. The unit here only works with ASCII. It can't use previous encodings like the IBM mainframes used, like the teletypes used. This is an interesting kind of transition piece between mainframe, is it EBIDIC? I can never remember how to pronounce it. The IBM encoding for characters. The transition from that era to ASCII, from teletypes, which would have been, your options in 76, 75, when this was available as a hobbyist, might have been like a used teletype if you get your hands on one. There were, it's called a glass terminal, a terminal with a CRT in it. Those are being manufactured. They were horribly expensive and way out of the reach of the average home computer user. This was designed to be used with the Southwest Technical Product 6800 computer. Of course, it could have been used with any computer that understood, there was an ASCII machine, the M-Size, the Altars, the Chromicos, all those machines. This could have potentially been used as a terminal with them. can see whoever built this harness here didn't do a great job with the wiring. I've looked at this several times and thought I should clean this up. I've got some other parallel ASCII keyboards, but they have a numeric keypad. Well, you can't see me, my hand waving out here, off to the right side, and so they'd be wider than this keyboard. And really wouldn't mount well in this configuration. You know, reading through the manual, it talks about the fact that the 2102 RAMs, let me move the camera up a bit so you can kind of see a little better what I'm gesturing at. I'll try to get the focus a little more here. These 6 2102 static RAMs would have been very expensive at the time. The character generator is sitting right here. It's essentially a ROM. Those were very expensive at the time. The UART chip, the General Instruments UART chip on here, I believe was a pretty spendy part. Pretty much everything else on it's just Jelly Bean TTL Logic 7400 series. So, you know, nothing too fancy there. Way back here in the back, there's a couple of large transistors sitting in cans. I haven't looked to see how they do the level shifting from the, you know, the UART's a 5-volt part to the plus and minus 12 for the RS-232. I don't know if the 1488 or 1489 level shifters were even available then. I'd have to look at the schematic on this. There are some adjustments that you really can't see here on the board for setting vertical positioning. Those kind of things. However, this came right up. It had good vertical positioning on the monitor I threw at it. We'll get back around here. We've got a fair amount of glare coming in from over here. I apologize for that. See if I can mask that a bit. Nope. Yeah, that's just very bright. Apologies for all that glare. I didn't notice it earlier. Cover off an old oscilloscope there. It makes kind of a shield. Well, let's keep typing on here and see what else we get. So Control M beginning a line, Control J down. Back to beginning a line. Oops, Control M. I'm holding down the wrong key. Wow. You hear me complain about typing. Here I go again. This is a test. Control M. Control J. 10 characters. 20. 30, 31, and 32. That is the width. So 32 characters wide by 16 lines. I should be able to Control M or Control J here, and it'll flip over to the other screen, the other half of the video memory. And when I get at the bottom of this screen, it should flip back to the side screen we were on. I got to be really careful here and not hit one too many. Oh, I managed to scroll it off and clear it apparently. So and some key bounce. That's just wonderful. I don't believe this keyboard does end key rollover or anything. It's a very basic keyboard. CT-1024 Terminal. Sold as a kit. Oh, that's a shame. Get back to the beginning of the line. There's articles in Radio Electronics magazine. You saw it do the wrap around there as it got to the 32nd character. Describing, now it looks like it's spelled wrong, the system along with construction articles. Now this, we go back to the mid-70s. This would have been absolutely an amazing addition to a home computer of the era. If you look at the MSI, the Altair, those early machines, they didn't come with video hardware. They came with just a RS-232 port that you hooked up to a terminal, a teletype, some kind of device to actually interact with the computer. It just, it wasn't given. There was no video board in the machines, nothing like that. It just, ASCII data being spit in and out of a serial port. So you would have taken the serial port from them and you would have built up a cable and plugged it into here and actually been able to interact with the machine, with the proper software. So this would have been absolutely astonishing to have in your home at the time. There is a modification for the unit that'll convert this to 64 character by 16 line. That actually becomes useful at that size. It's fairly involved, a lot of trace cuts and that kind of stuff, and I really don't want to do that to this unit. It's in too good a shape to do that too. It's pretty clean overall. The build quality is okay. It's just a nice little artifact. It's one of those things that it's rare. I only know of a couple others that exist. I'm sure there's more out there. Michael Hawley has a collection. He's restored several. He's built custom cases. He's done some really nice work on these. The documentation I downloaded here, so the pages of information here come from Michael Hawley's website. If you just search SWTPC CT-1024, you'll find Michael's site. He's taken all of the original documents and he's cleaned them up. Reworked the manuals, very nice as PDFs. In some ways I like having the old original manuals. It's more charming, but he's done an excellent job documenting the system. Like I say, restoring a few. I've seen a couple of his. There's a computer meetup in Redmond he comes out to occasionally and will bring his stuff out, and he's always interesting to talk to. He was part of the computer scene here in the Seattle area back in the 70s. A lot of history, a lot of knowledge. Really interesting guy. I encourage you to search for his website. I don't have the URL here with me, but Southwest Technical Products, SWTPC CT-1024. I think he's like the first page that'll come up. Just lots of good information. I really thought this video was going to take longer than this. I really expected this to turn into a repair video. I'm 21 minutes, it looks like, into this piece of the video here. So I've rambled on for 21 minutes and the system stayed up. The 5-volt supply has dropped off. It's down around 4.98 volts. No surprise, the junction in that 2N3055 is getting warm. It's hot enough to become uncomfortable, but not hot enough on the heatsink. I just stuck my finger on the heatsink. That it's jeopardizing the transistor. See, I'm not surprised the voltage just kind of rolled off as the power supply is heated up. This again is that original cursor card. It was just so interesting flipping through stuff on eBay and just seeing the picture of this come up, and I instantly knew what it was. I have not installed it. There's actually a little bit of rough handling here on the back. The traces aren't cut all the way through, those ground traces, but it's been stacked on something. Again, the assembly job isn't horrible. It's not awesome. There's Rosie. She wants attention, as she always does. Rosie, shush. Actually, before I end it here, let's just run through the character set and see what all we can get out of it. So let me go back to the beginning of the line. Rosie, I'm recording video. They don't want to hear you bark. I don't want to hear you bark. So didn't get the tilde. Doesn't seem to be an open brace. So there's characters it's just not recognizing. The pipe symbol's not recognized. And now she's going to choke. Poor girl. I've mentioned in a few videos that she's got a medical condition going on. Oh, interesting. Control. Rosie, enough. Control close bracket actually homes the... Oh, now it's typing them. Oh, shift. So the closed curly brace actually returns the cursor back to the beginning of the line as well. I think I've already ran through most of those characters. The vast majority of the characters are here. See, it doesn't have the open or closed braces, which I find interesting, or the tilde. Of course, there's no tab. There's no escape. Control G won't ring a bell because there's no bell on it. Control G back in the day rang the bell on the terminal. Control M is carriage turn. Control J is line feed. You get back to the old terminals, you needed to know those things. In your software. Well, I'm continuing to ramble, and Rosie obviously wants attention, so I will end this here and probably add to it down on the mixing computer. We'll talk soon. Bye.